This is an AQA GCSE Chemistry Paper 1 higher tier from June 21. This question is about carbon and its compounds. Fullerenes are molecules of carbon atoms. The first fullerene to be discovered was Buckminster fullerene C60. What shape is a Buckminster fullerene molecule? Remember, it looks like a football, so you can say ball-shaped or spherical. Give one use of fullerene. Remember, it's used in nanoscience, so it can be used to deliver medicine or drugs. It can also be used as an antioxidant. Hydrogen storage can be used as a lubricant. Many options. Propanone is a compound of carbon, hydrogen, and oxygen. Figure 1 shows a dot and cross diagram for propanone. Complete figure 2 to show propanone molecule. Use a line to represent each bond. I'm just going to draw it here so I can see I've got a carbon, 3 hydrogens, carbon, and look, there's a double bond there to oxygen, carbon, 3 hydrogens. Remember, when you draw these, carbon forms 4 bonds, hydrogen forms 1 bond, oxygen forms 2 bonds, and as long as you follow that, you make sure you have the same number of hydrogens, 1, 2, 3, 4, 5, 6, 1 oxygen, 3 carbons, you can't really go wrong. Determine the molecular formula of propanone. With this, remember, it's the actual number of atoms of each element. So start with your carbons. How many carbons? 1, 2, 3. Next up, hydrogen. How many hydrogens? 6. And then lastly, oxygen. Propanone is a liquid with a low boiling point. Why does propanone have a low boiling point? Because it is a simple molecular structure, which means it has weak intermolecular forces. So it's this one here. You can't ever write covalent bonds are weak and intermolecular forces are strong. It makes no sense whatsoever. 1.6. Figure 3 represents the structure of graphite. Explain why graphite is a good electrical conductor, is soft and slippery. Give your answer in terms of structure and bonding, and it's worth 6 marks. Now, if you're writing a really fancy answer here, you'd say, in graphite, each carbon atom is bonded to 3 others, meaning you can actually see that here. 1, 2, 3, meaning there is a delocalized electron per carbon, which is free to move throughout the structure and can carry electrical charge. Why is graphite soft and slippery? Graphite atoms are arranged in layers. Again, here's a layer, and actually you have these weak intermolecular forces between the layers, which are easy to break. They need little energy to overcome them, meaning that it's soft and slippery. This question is about atomic structure in the periodic table. Gallium is an element that has 2 isotopes. Give the meaning of the term isotope. Give your answer in terms of subatomic particles. You must learn these definitions off by heart. So an isotope is atoms of the same element with the same number, and here's our subatomic particles of protons, but different number of neutrons. Table 1 shows the mass numbers and percentage abundances of isotopes of gallium. Calculate the relative atomic mass of gallium. Give your answer to 1 decimal place. So in order to calculate the relative atomic abundance, remember what you do is you take the mass number and multiply it by the percentage abundance, and then you take the second mass number, multiply it by the second percentage abundance and divide it by 100. So I'll write that out for you. Our answer there is 69.8. So we don't even need to touch it because there you are, 1 decimal place. Gallium is in group 3 of the modern periodic table. Give the number of electrons and neutrons in an atom of the isotope 6931. So this down here is the atomic number, otherwise known as the proton number, which is the same as the electron number. So its number of electrons is 31. To find the number of neutrons, you do the difference between these two numbers. So that's 38. What is the most likely formula of a gallium ion? Gallium is in group 3, which means it has 3 electrons in its outer shell. Therefore, to form an ion, it loses 3 electrons. An electron has a negative charge, so therefore it will become positive, and that answer there is 3+. Gallium was discovered 6 years after Mendeleev published his periodic table. Give 2 reasons why the discovery of gallium helped Mendeleev's periodic table to become accepted. Remember that Mendeleev left spaces for undiscovered elements, so gallium would have fitted into that, and he also predicted the properties of these undiscovered elements, so he correctly predicted the properties of gallium. This question is about the extraction of metals. Element R is extracted from its oxide by reduction with hydrogen. The equation is the sum of the relative formula masses MR of the reactants is this. Calculate the relative atomic mass of R. So we've been told that this is 150. What's this MR over here? 6. And then 3 lots of oxygen is 48. So add those together to get 54, which means the difference between these two numbers must be the MR of R. So do 150 minus 54 to get 96. Identify element R. You should use your answer in 3.1 in the periodic table. So we know its mass is 96. Let's make sure we're looking at the top number. We're looking for 96. It's molybdenum. Carbon is used to extract tin from tin oxide. The equation for the reaction is this. Calculate the percentage atom economy for extracting tin in this reaction. So let's write the equation. Percentage atom economy. Remember, it's the MR of the useful product, in this case tin, divided by the MR of reactants times by 100. So we know here our atomic mass is 119. Let's work out this MR over here. So we do 119 plus 2 lots of oxygen plus carbon. So that's 163 times by 100. So our answer here is 73%. Tungsten is a metal. Tungsten is extracted from tungsten oxide. All other solid products from the extraction method must be separated from tungsten. Table 2 shows information about 3 possible methods to extract tungsten from tungsten oxide. Evaluate the 3 possible methods for extracting tungsten from tungsten oxide. So evaluate means give the advantages and disadvantages of each. So if we're using carbon as the reactant, good things are that it is a low cost. However, bad thing includes the carbon dioxide gas, because remember that's greenhouse gas leading to global warming. If we take hydrogen, bad thing is that it has a high cost, but the products are good because you only get water vapour, so that's very clean. Iron, low cost, so that's good. Products, iron oxide solid. Because these are both solids, it's going to be hard to extract the tungsten. So let's form our argument using carbon and iron is good because they are both low cost compared to high cost hydrogen. Major disadvantage of using carbon is the production of carbon dioxide. advantage of hydrogen method is clean water is made that will readily escape and be separated from your tungsten because it's a vapour. And then that final method, method 3, involving iron method, involves solid iron oxide being made, which is hard to separate from solid tungsten. Give 2 observations you can make when a small piece of potassium is added to water. Remember, you get a flame because it's quite a violent reaction. It's a lilac coloured flame. You could also say that the potassium melts. Other options include that it floats, moves around, becomes smaller, and fizzing or effervescence occurs. Remember, that's the hydrogen escaping. Complete the equation for the reaction of potassium with water. Balance the equation. Handily, I just said that hydrogen is made. Remember, it's a diatomic molecule. Now, you're going to make potassium hydroxide. Just to show you, the charge on the potassium ion is +1 because it's in group 1. Hydroxide, remember, you need to learn this for me. It's OH-. And so it's quite straightforward to write the formula KOH. Now check for balancing. At the moment, we've got too many hydrogens on the right-hand side, so we need to add a 2 here, which means we now have 2 oxygens, but only 1 oxygen there. So add a 2. We now have 2 potassiums, so add a 2. Now let's double check. 2 potassiums on the left-hand side, 2 on the right. 4 hydrogens on the left-hand side, 2 hydrogens plus 2, so that's 4 hydrogens on the right-hand side. 2 oxygens, 2 oxygens. And now I've got my 2 marks. Explain why the reactivity of elements changes going down group 1. It's worth 4 marks. It was very vague, the fact it says changes. So let's first of all state what actually happens. As you descend group 1, remember for me that elements become more reactive. But why is that? Well, remember, reactivity is all to do with gaining a full outer shell. When they're in group 1, they'll lose 1 electron to gain that full outer shell. So we need to understand, why is it easier to lose an electron as you go down the group? Because the atoms are larger. Why? Because they have more shells of electrons. What does that mean? It means that the outer shell electron is further from the nucleus. As a result, it will be less tightly attracted and more easily lost, which explains why it's more reactive further down the group. Sodium reacts with oxygen to produce the ionic compound sodium oxide. Oxygen is a group 6 element. Draw a dot and cross diagram to show what happens when atoms with sodium and oxygen react to produce sodium oxide. So we've got a metal and a non-metal, because sodium is a metal, oxygen is a non-metal, which means we need ionic bonding diagram. I'll just show you what happens here. Sodium is in group 1, so it has 1 electron in its outer shell. They've told us oxygen is in group 6, so it has 6 electrons in its outer shell. So here's the outer shell of sodium. Remember, it's going to donate an electron to the oxygen here, but unfortunately for the oxygen, it's still not full. So what we have to do is bring a second sodium in, and that electron will be donated from the second sodium atom. So effectively, this shell here becomes the new outer shell. So we'll show that by drawing the outer shell again. Label your atom. Look, it has a full outer shell. Because it's lost an electron has a negative charge, which means it has a net positive charge. Remember, I said you need 2 sodiums, so draw exactly the same again. And then lastly, just get your oxygen sorted. Use the dots to show that it's a different element. Remember, it's gained 2 electrons from sodium, which means it has a 2- charge. Why is oxygen described as being reduced in the reaction? Because, remember, oil rig, the mnemonic, reduction is gain of electrons. Explain why sodium oxide has a high melting point. This is a chemical structures answer. Remember, because it's a metal and a non-metal, it is a giant ionic structure. So we need to identify the structure, which means it has strong electrostatic forces of attraction between oppositely charged ions. You must learn these key answers. Remember, my revision guides are full of these. And then always qualify the amount of energy needed to break those bonds. This question is about salts. Name the salt produced by the neutralization of hydrochloric acid with potassium hydroxide. So the salt name always starts with the metal and then the acid. So it will be potassium. And remember, hydrochloric acid forms chloride salts. Write an ionic equation for the neutralization of hydrochloric acid with potassium hydroxide. So we just want the ions. It's a simple neutralization equation as they told us above, which is why this is your answer. Soluble salts can be produced by reacting dilute hydrochloric acid with an insoluble solid. Copper, copper carbonate and copper oxide are insoluble solids. Which of these insoluble solids can be used to make the copper salt by reacting the solid with dilute hydrochloric acid? So we're going to be making copper chloride. We need to understand quite a lot about these. First of all, it's not going to work with copper because copper is less reactive than hydrogen, which means it will not react with hydrochloric acid, so that won't work, which means only this option will work. That requires an awful lot of in-depth knowledge, actually. A student makes crystals of magnesium sulfate. This is the method used. Add sulfuric acid to the beaker, warm acid, add spatula of magnesium oxide, stir, repeat until there's magnesium oxide remaining in the beaker, filter, evaporate, leave the solution to finish crystallizing. Give one reason for step 2, 5 and 6. So why did we warm the sulfuric acid? To increase the rate of reaction. What was step 5? Repeat steps 3 and 4 until there's magnesium oxide remaining in the beaker. And that's to make sure all the hydrochloric acid reacts. And then step 6, filter the mixture. Why? To remove excess magnesium oxide. How should the filtrate be evaporated gently in step 7? Key word here is the fact that it needs to be gently done, so a good thing to use here is a hot water bath. Iron chloride is produced by heating iron in chlorine gas. The equation for the reaction is this. Calculate the volume of chlorine needed to react with 14 grams of iron. You should calculate the number of moles of iron used, the volume of chlorine. I don't really like all that calculation bit. That makes it look quite hard, I think, all those steps. Let's just go for it. So we'll steal that equation. If you've been following me for a while, you'll know I like to use a table method. This is how you should lay out your answer. Mass, MR, moles. Remember your formula triangle looks like this. Please remember that mass goes at the top. So being asked to find the volume of chlorine needed. So I'm going to put an X under moles. That will become clear why later. We have 14 grams of iron. What's that mass of iron? It's given here, 56. So what's the number of moles? Well, you do cover moles, so you can see it's mass divided by MR. 14 divided by 56 to get 0.25. And then check the mole connection, it's 2 to 3. So in terms of the number of moles of chlorine, divide 0.25 by 2, multiply it by 3 to get 0.375. And then lastly, we need to find the volume of chlorine needed. And the way you do that is by doing that number of moles you've just calculated, timesing it by 24. You must learn this because after all, if 1 mole occupies 24 decimeters cubed, what volume does 0.375 moles occupy? 9 decimeters cubed. So yeah, that's why I didn't really get too intense with this bullet point list because I knew I'd get the answer with my table. This question is about metals. Table 3 shows information about 4 substances. Which substance could be a metal? Well, we're looking for high melting and boiling point, and also that it conducts both in solid and liquid state. That's obeying all my criteria. We explain why alloys are harder than pure metals. Again, this answer needs rote learning. Alloys are made up of atoms of different sizes. And what that does is it means that the layers of atoms can't slide over each other as easily. Because the layers have been distorted. A student wants to compare the reactivity of an unknown metal Q with that of zinc. Both metals are more reactive than silver. The student is provided with silver nitrate solution, metal Q powder, zinc powder, a thermometer, normal laboratory equipment. No other chemicals are available. Describe a method the student could use to compare the reactivity of metal Q with that of zinc. Your method should give valid results. The point here where it says your method should give valid results, it means that you have to be measuring something, and the most sensible thing here is to use the thermometer to measure temperature change. Because the more reactive the metal, the higher the temperature increase. And so what you're going to do is take metal Q, add it to the silver nitrate solution, and then you'll measure the temperature change, and then we'll repeat that using zinc. It's always important, because we're looking for valid results, list a couple of control variables. So that could be the mass of metal powder added, could be the volume of that silver nitrate solution. So we're ready to get going. Measure the temperature change when zinc is added to silver nitrate using the thermometer. Repeat using metal Q. The greater the temperature change, the more reactive the metal. And then in terms of control variables, well, we mentioned we want to keep the mass of metal the same each time, and the volume of silver nitrate. And in that way, I've answered this point about how we're comparing the reactivity, and I've described how we're going to get valid results. This question is about chemical reactions and electricity. Electrolysis and chemical cells both involve chemical reactions and electricity. Explain the difference between the processes in electrolysis and in a chemical cell. Oh, this is quite a hard question. Remember, the word electrolysis means using electricity to break apart an ionic substance, so in effect to cause a chemical reaction, whereas a chemical cell actually uses a chemical reaction in order to produce electricity. A teacher demonstrates the electrolysis of molten lead bromide. Bromine is produced at the positive electrode. Complete the half equation for the production of bromine balance. Okay, so bromine, remember, is a diatomic molecule, which means it exists as Br2. Let's get that balance by adding a 2 there. And then because you've gone from something which is negative to something which is neutral, effectively you've removed electrons, because remember, electrons are negative. How many have you removed? It's 2. You might also have seen this equation like this, which probably makes a little more sense. Because look, there you are removing those 2 electrons. But because of how they've laid it out in the question, we have to answer it that way round. 2 aqueous salt solutions are electrolyzed using inert electrodes. Complete table 4 to show the product to each electrode. Now, because we've been told they're in solution, it means there's also H plus ions and OH minus. So the rule at the positive electrode is that you produce a halogen, and if there's no halogen in solution, you produce oxygen. We haven't got a halogen, we've only got nitrate. And then for potassium iodide, there's the halogen, so we're going to make iodine. But now you need to decide, are you going to make K plus or H plus at the negative electrode? Remember, it's the least reactive element here, which is why it's hydrogen. That is quite hard, actually. Some students investigated the electrolysis of copper nitrate solution using inert electrodes. The students investigated how the mass of copper produced at the negative electrode varied with time and current. This is the method used. Weigh the negative electrode. Set up the apparatus as shown in figure 4. Adjust the power supply until the ammeter shows a current of 0.3 amps. Switch off the power supply after 5 minutes. Rinse the negative electrode with water, allow to dry, reweigh, and then repeat steps 1 to 6 for different times. Repeat steps 1 to 7 at different currents. Some of the copper produced did not stick to the negative electrode but fell to the bottom of the beaker. Suggest how the students could find the total mass of copper produced. So we need a way of getting that copper out of the solution. So the first thing you need to do is filter it. So remember, here's your funnel with your filter paper. And then you pour that mixture of copper nitrate solution with the copper through the funnel. It should collect in the filter paper. You allow it to dry to get rid of any excess water and then weigh it, and that will tell you the mass of copper. Importantly, remember you need to add it to the mass that was already on the negative electrode. The students plotted their results on a graph. A student correctly concluded that the total mass of copper produced is directly proportional both to the time and to the current. How do the results in figure 5 support the conclusion that the total mass of copper is directly proportional to the time? Well, it's a straight line, and also the fact that it passes through the origin. Always look for it passing through the origin. If it does, it's directly proportional, as long as it's a straight line. If it doesn't, then it's not. It's just linear. How do the results in figure 5 support the conclusion that the total mass of copper produced is directly proportional to the current? Use data from figure 5 in your answer. Okay, so notice, because before that x-axis had a scale, it was time in minutes. Now we're comparing currents. So really we need to look at a particular time. So say at 20 minutes, we've produced 0.12 grams. And then for the 0.6 amps, we've produced 0.24 grams. And look, the mass produced has doubled, which means that this relationship is also directly proportional. So when current doubles, mass doubles. Let's give some data. Copper nitrate solution is blue. Suggest why the blue colour of the copper nitrate solution fades during the electrolysis. It's because what's making it blue is those copper ions, and remember they're being discharged to produce copper, so effectively they're no longer there in solution. Determine the number of atoms of copper produced when copper nitrate solution is electrolyzed for 20 minutes at a current of 0.6 amps. Give your answer to 3 sig fig. Here's your mass of copper, and Avogadro's constant is this. Don't stress about this. I know it looks almost like we've dipped into physics here with this time and current, but use your knowledge of mole calculations. Remember, this formula triangle states that mass is mR times the number of moles. So we know we need to find the number of moles, but how can we find the mass? Well, we know that we're looking at 20 minutes with a current of 0.6 amps. And remember the mass here, handily I've already worked it out, was 0.24 grams. We know the MR or AR of copper is 63.5. And then lastly, how do we work out the number of atoms? Well, we multiply the number of moles by Avogadro's constant to get to 3 sig fig. This question is about the reaction between hydrogen sulfide and oxygen. What does H2OG represent? Well, first of all, that's water, and it's in a gaseous state, so you could write water vapour, steam, gaseous water. Calculate the volume of oxygen required to react with 50 centimetres cubed of hydrogen sulfide. You need to check this mole connection, so you need to take that 50, divide it by 2, and then times it by 3. So you need 75 centimetres cubed. Figure 6 shows part of the reaction profile for the reaction. The reaction is exothermic. That means that energy change is negative. Always write notes to yourself. You should complete the profile line, label the activation energy, label the overall energy change. So let's steal the products here. We need to copy those out. Because it's an exothermic reaction, those products need to be at a lower energy. Here comes our profile line. Now the activation energy is the minimum energy required for the reaction to take place, which is why it's this line here. So I've done those two steps, and there's your energy change, which remember is the difference in the energy between the reactants and the products. Figure 7 shows the displayed formula equation for the reaction. Table 5 shows some bond energies. In the reaction, the energy released forming new bonds is 1034 kJ per mole greater than the energy needed to break existing bonds. Calculate the energy X for the SO bond. Okay, they've been quite mean with this one, but I promise we can work this out if we follow these steps. So the equation we need is bonds broken, take away bonds made, equals energy change. Let's list the bonds broken. So we're looking at this side. We have 4 HS bonds. So 4 times 364. And we have 3 O double bond O bonds. So add those numbers up. What about our bonds made? We've got 4 OH bonds, so 4 times 464. And then 4 OS bonds, which is what we're after. So 4x. Now be very careful with the wording of this question. It says that the energy released forming the new bonds is 1034 greater than the energy needed to break bonds. So effectively, the difference between these two sets of numbers is 1034. So actually, you want to do this calculation. It kind of deviates from your usual way of working out these questions. So we're not using this equation here, but we did need it in order to set ourselves up. And then you have to solve it. So do 1856 minus 2950. And then how do you get 4x by itself? Well, you add 1094 to both sides, and then finally divide by 4. This question is about acids. Hydrogen chloride and ethanoic acid both dissolve in water. All hydrogen chloride molecules ionize in water. Approximately 1% of ethanoic acid molecules ionize. A solution is made by dissolving 1 gram of hydrogen chloride in 1 decimeters cubed of water. Which is the correct description of this solution? Okay, so HCl here is a strong acid. So we're looking for strong acid. And we've got a teeny tiny mass in a large volume of water. So it's a dilute solution of a strong acid. Which solution would have the lowest pH? So low pH means strong acid, which means again we need HCl and we don't want ethanoic acid. And then you're looking for the highest concentration, which is this one, so it's that final option. A student investigated the concentration of a solution of sodium hydroxide by titration with 0.048 moles of ethane dioic acid. This is the method used. Measured 25 centimeters cubed of sodium hydroxide solution using a pipette. Add indicator. Fill the burette with the ethane dioic acid. Add the ethane dioic acid to the sodium hydroxide solution until the indicator changes colour. Read the burette. Suggest 2 improvements to the method that would increase the accuracy of the result. We need to talk about this being added drop-wise. Remember, just a single drop of that acid will cause that indicator to change colour. You also want to continually swirl the flask to make sure everything's mixed. So you need a really in-depth knowledge of how to carry out a titration here. Ethane dioic acid is a solid at room temperature. Calculate the mass needed to make 250 centimeters cubed of a solution with a concentration of this. You need 2 formula triangles here. Your usual mass, MR, number of moles, because after all you're being asked to find the mass. But in order to do that you need to find the number of moles, so you need to find the number of moles using concentration times volume. Our concentration, we've been told, is 0.048. Our volume is 250 centimetres cubed. Be careful, that needs converting to decimeters cubed by dividing by 1,000. These questions are really tough, by the way. And now we're ready to find the mass of that acid by doing the number of moles, which we just calculated, times by the MR, which was 90. 1.08 is our answer. That's an awful lot of work for 2 marks. A student found that 25 centimetres cubed of sodium hydroxide solution was neutralised by 15 centimetres cubed of 0.048 mole ethane dioic acid. Calculate the concentration. Okay, this is actually, in my opinion, more chill because we just follow this approach. We steal that equation, rewrite it in the exam. We make a table. We put NCV in it. Then we put in all the numbers we've been given, such as the volume. Get that into decimeters cubed immediately by dividing by 1,000. We know we have 15 centimetres cubed of the acid, so that goes in there. Its concentration was this. And we're looking for the concentration of sodium hydroxide. So hopefully you can see we've got all the information we need to find the number of moles, which, remember, was concentration times volume. So multiply those numbers together. So that's 7.2 times 10 to the minus 4. Check the mole connection. It's 1 to 2, so you need to multiply that number by 2. And then when you've done that, you have the number of moles of sodium hydroxide. So then it's a matter of finding your concentration by doing number of moles divided by volume. So your final answer here is 0.0576.